isothermal process, constant temperature process. Means if you are taking a thermodynamic process, throughout the process the system temperature remain constant. You might have seen that when the transition of the stages is coming like from solid to liquid, when the transition is taking place, that is taking place at constant temperature. For example, ice melts at 0 degrees Celsius. Throughout the melting of ice, you can see that the temperature of the system remains 0 degrees Celsius. Just like that, when the boiling water is getting converted into water vapor, that process also is taking place at a constant temperature, that is 100 degrees Celsius. So isothermal process is a constant temperature process. Now here the thermodynamic process, the system is actually a gas taken in a cylinder. So if you want to keep that gas at constant temperature throughout the expansion and compression process, we must consider two conditions for it. One, the cylinder in which the gas is taken should be a conducting walled cylinder. The wall of the cylinder must be a conducting wall. That whenever there is a change of temperature is coming, that temperature must be exchanged with the surroundings. For that, the heat must be conducting to the wall of the cylinder. Excess heating comes inside means that heat energy must be released to the surroundings. If there is a decrease of energy coming, then from the surroundings the energy must be absorbed by the gas inside. So for that, the cylinder must be a conducting wall one. And another condition is that the process, whether it is an expansion or compression, it must be a very slow process. So that if there is any change or exchange is needed, then the system must get enough time for that. So the system must be having a conducting walled cylinder, then the process must be a very slow process. These two are the conditions required for an isothermal process. Now details regarding this one, that's what we require here are equation of state of isothermal process. It is PV equal to a constant. Pressure into volume remain a constant. Okay. Then the indicator diagram for isothermal process. Indicator diagram is actually a pressure volume diagram. Volume taken along x-axis and pressure along y-axis. So according to this equation, the indicator diagram will be of this shape, hyperbolic. Okay, if I put an area like this, arrow like this, then it shows that an isothermal expansion. If the arrow is other way around, then it must be an isothermal compression. Okay. Then next thing is that slope of the isotherm. What is an isotherm? This line is called an isotherm. An isothermal curve is called an isotherm. So slope of this isotherm, you cannot draw the triangle and find out as usually you are doing from a graph. It's not possible here. So we must go mathematical to find the slope of this one. So actually when you draw a graph and to find the slope of the graph, actually the slope means slope is equal to change along y-axis divided by change along x-axis. Change along y-axis divided by change along x-axis. So in this particular case, it will be, instead of y-axis, we will be having what? Y-axis will be getting pressure, so change in pressure. X-axis we have taken the volume, therefore delta. So slope of this graph is nothing but is equal to change in pressure divided by change in volume. So this can be obtained from this particular equation. For that, what we need is P into V is a constant. This is the equation of state. Now if I differentiate this one, as we want the change, if I differentiate this one, we can say first function into change in second one, or differential of the second one, plus second function into change in the pressure. First function, that's pressure here, will be equal to change in the constant, or differential of the constant, that is equal to 0. So this is what I am getting if I apply differentiation for this particular equation. And therefore, from this I get P into delta V equal to minus of V into delta P. Okay. Therefore, as we want delta P by delta V as the slope, the delta P by delta V will be equal to minus P by V. So, slope of this isotherm will be equal to, slope of isotherm will be equal to minus P by V. Now, why there is a negative sign? Why there is a negative sign? This is always a question, because this graph is having a negative slope. Whether the expansion curve or the compression curve will be getting a negative slope because pressure and volume are inversely proportional. That means when pressure increases, volume decreases, and vice versa. Therefore, the slope will be a negative one. Okay? So, isothermal process. What are things required for all discussions? Equation of state, then slope of the isotherm, how to find out slope, and indicator diagram. Okay, for any process when we discuss these three are the main things required for our discussion. Okay, now we want to find the work done in isothermal process. That is the next thing. That work done can be obtained from this indicator diagram also. But that we will discuss in the next session. Okay. So if you want to find the slope of the thermodynamic processes, whatever it may be, you will be having an equation of state for that particular process. Take that equation and differentiate that and reach to the slope formula, that delta P by delta. Okay.